This problem is a classic kinematic problem, but with rotational motion instead of linear motion. So let's go ahead and write down all our knowns. We have a ceiling fan spinning initially at omega naught equals 60 revolutions per minute. That's what RPM is. And it eventually will stop in 25 seconds. So omega final will be 0, and delta time is going to be 25 seconds. How many revolutions does it make while stopping? So now we want to know delta theta. Okay, I think the first thing we want to do is to get it into SI units. So this is revolutions per minute, and that is not an SI unit. What we'll need to do first is get revolutions into radians and then minute into seconds. So let's go ahead and multiply this by how many revolutions per radian. So well, actually, how many radians per revolution. So we'll have revolution on the bottom. In this case, revolutions on top. So revolutions will cancel out. And then we multiply it by how many minutes per second. Minutes are on the bottom here, cancel out with the minutes here, and we have seconds left over. So now this revolutions per minute becomes a radians per second. Those are the only two that's left. Let me go ahead and make darker lines. Okay, let's go ahead and figure out what to plug in. How many radians per revolution? Well, in a circle, there are 2 pi radians per every turn around the circle. So that will be 2 pi radians per every 1 revolution. As for minutes per second, there are 1/60th of a minute per second. So the 60 can go down here. You could just say there's 60 seconds per every 1 minute. Now, if you do the calculation, this ends up being 2 pi radians per second. So something that looks nice. You could also say 6.28, but 2 pi just looks nicer on paper here. Okay, so it looks like we have everything we need to know. Let's figure out which kinematic equation has what is given to us and also what it's asking from us. Now, there's one that we barely use, so it's great that we're using it now. That is, well, in a linear sense, it's going to be x, or I guess like delta x, is equal to 1/2 velocity initial plus velocity final times delta t. So the rotation equivalent to that would just be delta theta is 1/2 omega naught plus omega f times delta t. And from there, it should be pretty straightforward. Omega naught is, as we've just discovered, 2 pi radians per second. Omega final is 0, and delta t is 25 seconds. So plug it into your calculator. Delta theta would equal to 78.5398 radians. And if you want to get into SI units, it looks like there's only 2 that's given. It will give you 79 radians. And that's how many times it turns in the 25-second slowdown. So slows down in 25 seconds, and it initially spins at 60 RPMs. It'll take 79 radians, which is going to be 79 divided by 2 pi turns before it eventually stops.